All right, this is the video for problem set 3, task 2, where I'm going to walk through what the requirements are. And I should have noted this in my first video, but I'll note it here. Tasks 1 and 2 are not tasks that you have to do both of them. You get to choose whether you want to do task 1 involving turtle drawing or task 2 involving music. So you have the option to decide which you want to tackle. We've done more stuff already on turtle drawing, but if you happen to be a big fan of music or want to branch out or you just hate turtle drawing, you have the option to do task 2 instead of task 1. Um, if you do both, I guess we'll give you the score for whichever one you got more points on. But it is not required or recommended that you do both. Choose one of tasks 1 and 2, do those. You have to do task 3 and task 4, no matter which one you choose for the first two. All right. Making music in this task, you will use a new library that we have provided for you called synth.py to put together this classic Irish jig. Now, you may have noticed a little bit of hesitation there, or some kind of way in which those notes weren't perfectly exactly the same as each other. And that's the twist of this problem set, or this task rather, that we have provided a random note function for you called add random note. It adds a note based on a intended duration, but it doesn't always give you exactly that duration of a note. Sometimes the note is slightly shorter, sometimes the note is slightly longer. And your job is going to be to use that random function, but also account for its randomness by taking advantage of the fact that it is fruitful and it returns the actual duration of the note that it added. So one of the things in the synth.py module is that you need to specify when each note should be added to the track that you are building. So we call functions to add notes to tracks, and then later on we call functions to play or save the track, and that's how we produce our music. In order for the notes to come one after the other, we have to know when the note starts and when it ends, right? And since the notes are random, we're going to have to use their return values to know when they end. All right. So because we have not yet used the synth.py module, you will have a little bit of a learning curve here relative to the turtle assignment. And if you want to just go ahead and choose task 1 for that reason, that's totally valid. There is a new reference page under the reference tab here. There is a music reference, and it's also linked here in the problem set. Like the turtle reference, this has a sort of rundown of all the different functions that there are in the module. It also has some detailed reading on the different concepts from music that you need to understand what's going on in the module. We've kept things simple. I hope that you don't even need to have prior experience with like reading music or anything at all to understand what's going on in this module. But if you do have prior experience with playing an instrument or reading music, that may help you a bit. The biggest thing that's going on here, and this is a little bit of sheet music notation, but don't worry too much. We think of these as lower and higher pitches, right? So notes can be low or high. And in musical notation, we label these as A, B, C, D, E, F, G. The problem is there's way more possible pitches that the human ear can hear well, even accounting for the size of the step we're taking, than just those letters. So we also give them a number. So this is C4, D4, E4, F4, G4, A4, B4, and then C5. Please don't ask me why it starts counting at C instead of A. I'm not the one who made up this system, and I kind of disagree with that choice. But this notation will be used to talk about where your notes should be in terms of being high or low. We have a separate notation that we also give you for simplicity's sake with P values, so P0 through P14. You shouldn't need to get too much into the details of this, but we will tell you, oh, this should be played at this pitch, which is D4 or whatever. And you'll have to make sure it does that. All right. The problem set also, besides this reference page, has a mini summary of the concepts that you'll need um, to use synth.py, and I'm going to go through those here. So you'll need to use the provided add random note, and that's the only function you'll use to produce notes. The reference has references to other functions you can use to produce notes, but for this problem set, just add random note. And like I said before, this function does not just play a sound. Instead, it adds it to a track, and later we can modify that track or save it or play it. And so what we'll be doing is calling a bunch of functions to add notes to our track, and then saving the track or playing the track to actually hear what it sounds like. There's also a wrinkle here. You will need this module called simple audio in order to be able to play stuff from Python. Otherwise, you're going to be stuck with save track, which creates a .wav file in the same folder, and you can open that WAV file in order to listen to what it sounds like. So you don't have to install this module, but since I'm making this video, I'm going to go ahead and show you how to do that. If I open up Thonny, which I'm about to do, there we go. All right, and I'm going to go ahead and just get rid of that for a second. If I go to the Tools menu here, there's a Manage Packages option. And if I click on that and search for Simple Audio up here in the top part. For me, it's already installed because guess what? I built this problem set and wanted to make sure it worked. But for you, there'll be a button here to install it. You just install it. It should work pretty simply. And after you've done that, then the problem set will be able to play music for you directly in Python. You won't have to open those WAV files afterwards. All right, add random note as a function has 3 parameters. So the start time for the note, when in the duration of the track does this note occur? The pitch of the note, so how high or low it is. And remember, we have those variables C4, D5 that we can use to specify pitches. And then the intended duration of the note. So maybe 0.2 seconds or 1 second. But the note it actually adds is between 90 and 110% of that intended duration. And the random note function or add random note function will return the actual duration of the note it added, just as like a floating point number. You need to keep track of those return values in order to make things work. All right, other functions you'll need. There's a step up function and a step down function. These functions, you can give them one pitch value, and they'll give you back another pitch value that is above or below that pitch value. So you don't need to memorize and worry about the A's, the B's, the C's, the D's. We'll tell you, oh, this should start at D4, and then it should go up 2 steps, and then down 2 steps, or up 2 steps, and then up 1 more step, right? And you can call step up and step down to compute those values. Step up and step down are functions that can take one argument, a pitch, and they just give you the pitch that's 1 step higher or lower. Or they can take 2 arguments, a pitch and a number of steps. And that number of steps can be positive or negative. If you give a negative number of steps to step up, you'll actually be stepping down, and vice versa for step down. So if you wanted to step up 3 steps, you could say step up of whatever your pitch value is, comma 3, and that would take you up 3 steps. These are fruitful functions. So you give them a pitch value, they give you back a different pitch value. You're going to have to catch that value in a variable. A common pattern will be to call step up or step down with a pitch variable and then store the result back into that same pitch variable so that you're modifying that variable to push it up or down. All right. If you're familiar with a piano, these functions are basically going up or down by white keys only. We're skipping over those black keys. And there are reasons for that, but you don't really need to know all the details of that. If you call these functions 7 times, that's what we call a whole octave. And that's a doubling if you go up or halving if you go down of the pitch value. All right. So you'll need these functions. You'll also need these variables that I already talked about that hold the pitch values. So C4 is a variable. You can't use the string C4, but you can use just the variable C4. And it holds a number. The pitches are just numbers. That is a certain pitch. So I talked about this stuff. Finally, there's print track, save track, and play track functions. All of these have similar purposes. print track will print out a nice summary of the notes that have been added to the current track. Save track actually saves it to a file in the given directory, and we have to give it the file name as a string. And then play track will just play the track. And all of these, except save track, take no parameters. Save track just takes the file name. How do they know what track we're talking about? Well, there's always what's called a current track. And for this assignment, for this task, you won't need to worry about that. You just call your add functions, then call these functions, and it knows to play the track that you added those notes to. Be careful with save track, it'll erase the file. So if you want to keep a copy of the file before you erase it, you might want to save a backup. Not usually necessary, but just in case. Also, save track and play track take some time to finish. These are not instantaneous, and that's because processing the notes that you've added and turning them into audio is a pretty intensive process, and Python isn't as efficient as it could be. And in fact, the synth.py module isn't as efficient as it could be at going through that process. So roughly, and again, it depends a little bit on your computer and other things, but roughly you can imagine it takes time proportional to the length of the track. So if I'm asking for 2 seconds of audio, I might have to wait 2 seconds for that to happen. It's a little bit better than that, but the longer your track, so the longer your note lengths, the longer it might take to play that back. What it does is it finishes all the processing first, and then plays the entire track. So you'll have some sort of period of silence, and then it'll play it back. All right, there's instructions here that I already went through for how to install that simple audio module. So this code here is just some demo code to give you an idea of how to write code for this module and to give you something you can test. So you can go ahead and copy this code and just paste it into a new file in Thonny. I'm going to go ahead and demonstrate the fact that this does not work. So to run my script, it'll ask me to save it. I'm going to save it as test.py, and I'm going to put it on my desktop. Sure, we'll replace it. All right, let's go, run it. Okay. Well, that's actually very interesting. It didn't fail in the way I expected it to fail. Probably because I already have a synth.py module on my desktop. In any case, the way I expected it to fail was that this import will not work because you need to save the file in a directory where you have synth.py. For example, the problem set folder that you downloaded in order to work on this problem set, right? That's how we provide you with that file. So make sure when you're testing, you use a directory where synth.py exists. But if you do that, then this code should be able to work. I'm not going to go through that process right now because I don't have a setup for it. This will play a simple scale, and you can in fact hear what it should sound like right here. Super simple. All right. There's some notes. I'm not going to go into all the details of this. You can read it on your own. But you can look at how this code is constructed. It has a pitch variable, and we start that based on an existing pitch variable from the synth module. So we'll start at this C4, which is sort of in the middle of high and low pitches generally. And we have this when variable for timing things, and we start that at 0. So we're going to add a note at 0 with C4 as the pitch. And keyboard just refers to which instrument we want, although you won't have to worry about that since you'll be using add random note for this assignment. Then, look, we say the duration of this note should be 0.2 seconds, and then we add 0.2 to our when variable. That means that this second note will be added starting at 0.2 seconds, right after the first note ends. And that's how we want to put our notes together in this assignment, is one after the other, touching but not overlapping each other. So I also take this pitch variable and I compute a value which is one step up from that, and then I replace the value of that variable with the new value. So I'm stepping up in pitch. Those two things are going to basically step me forward in time and up in pitch. And then I use those same parameters again, but now with different values. And I repeat that process over and over again, stepping forward by 0.2 seconds after adding a note with duration 0.2 seconds every time, and then stepping up by one white piano key and modifying that pitch value every single time. I have 1, 2, 3, 4, 5, 6, 7, 8 notes, so that is a full octave. Again, octave is this doubling of pitch. That's a pretty significant concept in music. Finally, I save the track, and then I play the track. And again, at this point, it'll pause for a little bit because it takes time to put everything together. All right. So what's the actual stuff you're doing for this assignment, right? I'm going to go ahead and play that jig one more time because this is our end goal. All right. That's complicated. There's a lot of stuff going on. But hopefully you could hear that there are some common themes throughout that song, right? There's the da 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 da. That's a theme that's repeated several times. What if we capture that into a function and just call that function multiple times? So your first subtask is actually a very general function. It's a function called 3notes, and it just adds 3 notes to the current track and gives you some parameters to control what notes those are. So there's a lot of 3-note patterns in that track because that's the basis of the song structure. And so having this function around will simplify everything else. It has 5 parameters. So the first one is the start time for the first note. Right? When are we going to start these 3 notes? The next parameter is the pitch of the first note. Right? What note are we starting at? The third parameter is the number of steps up, or if we give it a negative number, the number of steps down, between the first and second notes. So if we give it a number 1 for that third argument, then the second note is going to be 1 step above the first note. So we're going up. And then the fourth argument is the number of steps up or down between the second and third notes. So if we said 1, negative 1 for those 2 arguments, we'd start at 1 pitch, we'd go up a step, we'd go back down a step to the original note, and we'd have a da-da-da kind of pattern going on. Finally, we want the duration to be used for all 3 notes. So that's the intended duration of each of the notes. Not for all 3 notes together, but for each note. So if I give a 0.2 duration, then all 3 notes should totally be 0.6. Except we're calling random notes to add those notes. So we don't have precise control over the duration. And because of that, just like add random note is giving us back the real duration, 3 notes must be fruitful and it must return the true duration of all 3 notes that it added, right? So that if you want to call something else afterwards and line it up at the end, you can use that return value to figure out when the next 3 notes or add random note or whatever function should be putting its note into the track. All right, so we've provided a test function called test3notes. And this function uses random.seed to fix the random value that is generated by Python's random functions. So that add random note is going to add the same random sequence of notes every time, and it's actually dependable enough for us to test it. This is really cool. It does depend on adding your notes in the order that they appeared. So in theory, you could call add note 3 times and put the third note in first, right? You can't actually do that because of the random durations, but in practice, you're going to have to add the notes first, second, third, which kind of just makes more sense anyway. And so the intended duration here of 0.4 seconds, you'll notice these durations are not exactly that intended thing. They're a little bit higher or lower. You should be able to get this exact output with all these decimal values, and it should sound exactly like this. All right. That was 2 calls to 3 notes are in this test3notes function. And they have different parameter values to sort of test that it works for various values. All right. That is subtask A. When you have your 3notes function working and you're getting exactly this output, you're ready to move on. And we have this powerful ally, right? We have this 3notes function that we can tell it, start here, go up, then go down, or go up, up, then go down, 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 right? And it can add those 3 notes, and it is fruitful, so it'll tell us what the result will be. Now what we're going to do is define a number of functions that are all pretty much the same as each other. Each of these functions captures a specific pattern from the song, and these patterns are ones that we are going to repeat. So we want to capture them in a function to be able to call that function multiple times. Basically, each of these functions is just going to call 3 notes with particular parameters based on the parameters that it gives itself. So what are the patterns? There's an up, down, down pattern. That's the first 3-note pattern in the song. There's actually 2 lead-in notes to the song, although we'll get there in a second. So we start on a high note followed by 2 low notes that are the same as each other. It has only 3 parameters, not 5 like the 3 notes function does. So 3 parameters: start time for the first note, pitch for the first note, intended note duration for each of the 3 notes, right? These parameters should start to sound familiar. And it has these relationships between the notes. The second note is 2 steps below the initial note, and the third note is the same pitch as the second note, right? So you need to translate those relationships into parameters to add 3 notes, to 3 notes. And the body of up, down, down is just going to directly call 3 notes. Like 3 notes, up, down, down has to return the time at the end of the last note it adds, or the total duration of the 3, it's the time, not the duration. The time at the end of the last note it adds. And so to do that, it's going to have to return the same value that 3 notes does, right? So this is a function that is fruitful, but it does most of its work just by calling a different fruitful function. All right. We also have other patterns here. So down, up, up, guess what? Low note, high note, same high note. So the second note is 3 steps above the first note, and the third note is also at that same pitch. Middle, low, this is up, down, up. So the middle note is 2 steps below the first note, while the third note returns to the same pitch as the first note. All right, 3 falling is our last pattern function. So the second and third notes are each 1 step below the note before them. So it's 1 note, 1 step down, 1 step down. 3 notes in a falling sequence. Once we have defined all 4 of these pattern functions, it's time to define a function called phrase. Now, let me play that whole jig one more time and see if you can start to recognize these patterns. It's a little hard because I made things go pretty fast. Going fast is good because that means the file is shorter, so it takes less time to produce it. But there's a pattern where it goes high, middle, middle, low, middle, middle. Let me do it one more time. So da 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 da. I know my pitch is not quite on, but this is why I have my computer produce the notes for me. Those 2 patterns, and then listen. So we have that middle, low, middle, falling. The other 2 patterns that we defined. So those 4 are all together producing a larger pattern of 12 notes. And that 12-note pattern is actually repeated 3 times in the song. All right, go back down here. So we're producing a phrase function. It has 3 parameters. Guess what? A start time, a starting pitch, and an intended per note duration. Same as we're getting used to. Like the individual pattern functions, it has to return the end time of the last note it produces. Unlike those functions, it may not call 3 notes directly. Instead, it has to call each of those pattern functions once. So it has to call up, down, 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 up, up, middle, low, and 3 falling to produce that whole 12-note sequence. And here's a description of the pitches. So it starts with the provided bass pitch as the first note of an up, down, down pattern. Then it has a down, up, up pattern that begins 5 steps below that initial first note pitch. Then it has a middle, low pattern that starts on the same initial pitch as the first note. And finally, a 3 falling pattern that starts 2 steps above that initial pitch. So based on the initial pitch, we're doing that pitch, down 5 steps, that pitch, up 2 steps. And those are our 4 patterns that we're weaving together. We have some test code. So once you have produced it, this is what it should print with exactly these numbers because we fixed that randomness using the random.seed function. And here's what that sounds like. Slowed down a little relative to the jig at the top, so it's easier to tell what's going on. I'll play that one more time. All right. If you have your code working and you want to hear the relationships even more, you could give it a longer note duration to hear what that sounds like. So, finally, we're ready for the whole song. We have that phrase function, which we're going to repeat several times. And we're going to add a few notes here and there at the beginning, in the middle, and the end to just sort of put the whole thing together. So, this function, jig, is only going to have 2 parameters, the start time and the intended per note duration. And notice that the parameter that's missing is the pitch parameter. So the jig uses a fixed set of pitches rather than we supply it with a pitch and it can move up and down. So to start with, there's a 2-note lead in. This is before the first copy of that common pattern. And each note here is half of the standard note duration. So these are quick notes. So, right, we're given a standard note duration. We're using half of that for these first 2 notes. And these notes use specific pitches. So these D5 and C5. You can just use those variable names as the argument to add random note. And for these 2 notes, you should indeed directly call add random note. Now remember, just like everywhere else, you're going to have to capture that result value because you're going to need to be able to say, at the end of the day, where did we end up? And you're also going to need to put things back to back so that they line up with each other. All right, after those 2 lead-in notes, there are 3 copies of the pattern produced by the phrase function, right? So we're going to call that function. The first and third copies start on the note B4. The middle copy starts 1 step higher on C5. And again, you can just use these variable names as your parameters. After the 3 copies of the common phrase, there's a middle-low pattern. So we're actually adding another copy of one of those patterns here that starts on C5, followed by a new 3-note sequence. And it just uses these specific pitches, A4, D5, C5. You can use add random note 3 times. If you wanted, you can construct another pattern function to capture this pattern of notes. If you wanted, you could even call 3 notes to capture this pattern. Whatever you want to do, that's fine. Following that, there's an up-down-down pattern starting on B4. And finally, there's a single ending note that has twice our standard duration value and pitch G4. And again, all of these notes, whether they're added via the pattern function or middle-low or other functions, or just added ourselves in the jig, should be using add random note. So their durations are random. All right. You should only call add random note when you really need to. So that's the first 2 notes and the final note. All the other notes, ideally, if you want all the extra goals, should be produced using either 3 notes or one of these pattern functions or the phrase function. All right. So jig must return the end time of the last note it creates, right? Every function that we do should be returning that here is the end, right? Here's where I ended up. So that the next function can use that value to say, all right, you ended there, guess I'm going to start there. We have a test jig function. Here is the pretty long sequence of notes that it should produce. And that jig that I've been playing for you over and over again at the top of this website is what it should sound like. So a few notes to round out this description. Note 1, the names of your functions must match the names specified on the rubric and specified throughout this document. You are allowed to define and call extra functions if you wish, as long as they don't invalidate the rubric rules for which functions must call which other functions. So there's rules saying this must call that. As long as you're satisfying those rules, you can add your own extra functions. It says here, and I have said this before, the longer a song is, the longer it will take Python to process. So be patient with it. Using shorter duration values when testing can help alleviate this problem. When checking to make sure your printed output is correct, here's another link to that diff checker tool, which is super useful for checking whether something is exactly the same as something else. And then one final note, for grading purposes, your submitted code may not use the print function anywhere outside of the testing functions that we provided. You can go wild in those testing functions and add prints and whatever. And during debugging, you can add prints to see what's going on. That's a totally valid strategy. But you got to remove them before you submit. So no prints allowed. And that's because we use this printed output in part to check whether your function is doing the right thing. And if you have extra printed output, we will not be able to check that correctly. All right. Let me go ahead and go into the rubric. So it's always a good idea to look at these things and check them off because this is how you will actually be graded. So 3 notes. Well, guess what? It better create the correct notes. And it better return the correct end time. And here we're testing it with different random seeds, right? So we're having that add random note function do different things. It should work no matter what add random note does. Jig, just like three notes, should also create the correct notes and have the correct end time. And again, we'll test it with different seeds, and with each of those seeds, we'll test it with different parameters. Guess what? Our up, down, down, up, middle, low, 3 falling, and phrase functions, all of these functions, right, that we told you to define, they also better create the correct notes and return the correct end time, right? So we're just checking that things work, basically, with all of these different goals. All right, so here are the goals that relate to how you have to define the functions. We have to define 3 notes, and in 3 notes, we must call add random note in exactly 3 places. 3 notes, 3 random notes. Okay, pretty simple. We must not call add note, or add beat, or add rest. These are functions I didn't even talk about. I just want to make sure that people are calling add random note and not any of these other functions from synth.py. And then you have to call step up in at least 1 place, or you can call step down if you prefer, within 3 notes. All right, what else do we have to do? So up, down, up, middle, low, and 3 falling. These are our pattern functions, remember? Each of these must call 3 notes in at least 1 place. Big surprise, right? You're going to have to do that for correctness purposes anyway. And then phrase is a little bit more complicated. So it has to call up, down, up, middle, low, and 3 falling, all these pattern functions. And then it has to call step up itself in at least 1 place. Finally, jig. Jig has to call add random note in at least 1 place, right? It has to add some notes of its own. And then it has to call phrase in exactly 3 places. Again, these requirements that we have aren't necessarily sufficient to perfectly do everything. They're just the requirements that we have to make sure that your code is correct. All right, last core goal, do not use print outside of testing functions. So except for those testing functions, don't use print anywhere. All right, what are the extra goals? Well, we have some more tests in maybe trickier or different contexts than some of the other contexts that we've given you. And we have tests for 3 notes and for jig and for our various pattern functions, right? This is all kind of, I know there's a lot of goals here, but they're all kind of the same thing. What about how we define our functions? Well, for 3 notes, an extra goal is to call step up in exactly 2 places, no less and no more. For phrase, our goal is to call step up in exactly 2 places, no less or no more. And another goal is that we do not call 3 notes within phrase, right? Because we're going to call those pattern functions, which call 3 notes instead. So this is not about indirect calls, this is about direct calls. Finally, our extra goal for jig is that we call add random note in exactly 3 places, no more than is necessary. And for those other 3 notes that weren't one of the predefined patterns, you can do something else, like use 3 notes. All right, That is our rubric for PSO3 Test 2, and that concludes my video.